Good morning, students. So today in the first video lecture we are going to start with the first unit, that is vector and integral calculus. In that vector and integral calculus, vector and integral calculus. So in this, the first we have seen vector calculus before the lockdown. In that, first concept was that is the gradient. That is gradient. The second dealt was that is divergence. Divergence, and third one is curl. Okay, so here divergence means already I have explained, that is del f, where del is a that is differential operator and f is a that is a scalar point function, and this is del dot, this is del dot f. Okay, here again this del is a differential operator and f is that is vector point function, and here this one is del cross f. Okay, this is del cross f, so that already you people know. So these two we have studied. Okay, that is gradient and divergence we already studied. So now we need to see that is curl. What do you mean by curl? Definition of curl and the problems on this curl. Not only this curl, here there is one more the point will come, that is irrotation. That is irrotation. Okay, and even this irrotation also we need to see. So therefore in the first video lecture I would like to start with the third this one, that is curl. Third concept, that is curl. Now I'll go directly with the word, that is definition. What do you mean by the definition of curl according to what this particular mathematical equation? So now here the curl of the continuous differentiable, the curl of the continuous differentiable vector point function f, vector point function, otherwise I'll write here, vector point function f is equals to f1i plus f2j plus f3k is denoted by curl f, is denoted by curl f, and defined by that is curl f is nothing but del cross f. Okay, this is del cross f. That means del is nothing but, how will I write del? That is I dou by dou x plus j dou by dou x, sorry, dou by dou y plus k dou by dou z cross f1i plus f2j plus f3k. So now you know about the cross product of two vectors. So how will write? That is curl f is equals to del cross f is equals to determinant I j k. This is dou by dou x, dou by dou y, dou by dou z, and here this will be f1, f2, this is f3. Okay, so this is a definition of the curl of that is vector point function f. So therefore that is curl f is equals to, this is the main definition of that is curl. Now the next point is that is irrotation. What do you mean by irrotation? We need to see irrotation. So here we need to understand irrotation as that is what curl is equals to 0. If curl becomes 0, then that is the if curl of f is equals to 0, then we can call this f as what that is irrotational vector point function. So now here I'll write definition. A vector point function, a vector point function f, sorry, capital F, f is called, a vector point function f is called irrotation or irrotational. Irrotational if curl f is equals to 0. Okay, if curl f is equals to 0, or else you can say that is del cross f is equals to, that is 0 vector, not a 0, that is what 0 vector, because here that is the cross product will yield, that is so vector point vector function, so therefore that is 0 vector, that means 0I plus 0j plus 0k we can say. So now we shall see the examples on this curl. Okay, the first example so I am taking here is that is find the curl of examples. First one, find the curl of e to the power xyz, curl of f is equals to e to the power xyz in the bracket I plus j plus k, I plus j plus k at the point 1, 2, 3. So this is the example. Okay, by taking this example, so we need to find, that is what is the curl of that is vector point function f. So therefore here I'll take first what they have given. Let given is f is equals to e to the power xy z I plus j plus k, f is equals to e to the power xyz into the bracket I plus j plus k. If you elaborate this, you will get e to the power xyzi plus e to the power xyzj plus e to the power xyzk. You can call it equation number 1. Okay, so now you can find what is f1, you can very easily see what is f1, what is f2, what is f3. So this is f1i, f2j, f3k. That means f1 is e to the power xyz, and even f2 and f3 are also e to the power xyz. So therefore here I'll write f1 is equals to e to the power xyz, f2 is equals to e to the power xyz, and f3 is also e to the power xyz. So I have written that, right? So therefore f1, f2, f3 are known. So now what is the definition of curl? So that we have here. Okay, so here we can call it, otherwise you can call it equation number 1. Okay, so curl of f is defined in this particular fashion. So therefore by the definition of curl, we have, by the definition of curl, we have curl f is equals to del cross f is equals to determinant I j k dou by dou x dou by dou y dou by dou z. Here it is f1, f2, f3. Okay, so this is the definition. So now just keep as it is, replace by replacing f1, f2, f3 by e to the power xy z. So now that is equal to, so here we'll get determinant I j K dou by dou x dou by dou y dou by dou z, and here it is f1 is e to the power xyz, f2 is also e to the power xyz, and f3 is also e to the power xyz. So now use the definition of what that is determinant. Okay, I think you people know about this. So therefore here I'll be keeping here, take a square bracket, and now by leaving I is in the first place, okay, that is lies in what that is first place of first row and first column. So therefore first row and first column you have to leave, and remaining are these four elements, and now apply that's determinant toward these four elements. So therefore dou by dou y of e to the power xyz minus dou by dou z of e to the power xyz. So I'll write that dou by dou y of e to the power xyz minus dou by dou z of e to the power xyz. Okay, close the bracket. Similarly, next this element plus, here it is negative, minus j. Now leave the second row and first leave the second column and first row, then you will get this. So therefore dou by dou x of e to the power xyz minus dou by dou z of e to the power xyz. So write the same thing, dou by dou x of e to the power xyz minus dou by dou z of e to the power xyz. Close the bracket. Finally plus k, that is last element. That means third column you have to leave, third column and first row. That means first row, third column you have to leave, and remaining are these four elements, dou by dou x of this, dou by dou y of this. So therefore dou by dou x of e to the power xyz minus dou by dou y of e to the power xyz. Close the bracket. Yes, now elaborate this. Therefore here you will get, which implies that curl f or del cross f is equals to curl f or del cross f is equals to, now dou by dou y, that means for the partial differentiation of e to the power xyz with respect to y. Okay, that means x and z are kept constant and we are differentiating with respect to what that is y. Then what we'll get, exponential function will remain first as it is. That means e to the power xyz, if I have to write first as it is, and next x and z are they are treated as a constants and which are there with this y. So therefore here we'll get xz minus, okay, xz, because with respect to y we are doing. And now in the second element, so what we'll get there, that is with respect to z we are differentiating, so therefore e to the power xyz will be kept as it is, and xy will be treated as constant, so therefore here we'll write the constants. Yes, similarly minus j in the bracket e to the power xy z, with respect to x we are differentiating, so therefore yz will be written here, minus e to the power xy, with respect to x we are differentiating, sorry, with respect to z we are differentiating, so therefore here we'll get, that is xy. Okay, and close the bracket. Next plus last one with respect to, that's what, x, here e to the power xyz, and here with respect to x we are differentiating, so therefore this is yz minus e to the power xyz, with respect to y you are differentiating, so therefore here it is xz. Now close the brackets. Now which is equal to, what is common in all the terms, actually e to the power xyz, it is common, so therefore you take e to the power xyz as common, okay, outside. Then here what will remain in this is e to the power xyz you have taken common, here xz minus xy will get, and this I is already there, xz minus xy I. Next minus sign, here this is minus sign, so minus sign, so therefore here you will get yz minus xyj, and last one is plus k in the bracket yz minus xz, sorry, so k will write here. Okay, so this is the answer, right? So therefore curl f is equals to e to the power xyz in the bracket. Here if you want you can take x as common. Then if you take x common, then here you will get, that is z minus x, sorry, z minus y I. Okay, so here negative sign is there, I want to make it positive. That means if I send this negative sign here, then this becomes positive. So therefore in these two y is common, so therefore first I'll take y outside, and here this x I'll write first, and minus z, and this will be j, plus here what is common, here again z is common, take z common, then here we'll get y minus y minus, that is x, this is k. So that is x in the bracket z minus y I plus y in the bracket x minus z j plus z in the bracket y minus x into k. So this is the final answer. Okay, so therefore we'll check the answer. Yes, xz minus y. Yes, so this is a, yes, that is xz minus xy, yes, minus yz minus xy, then plus yz minus xz. Okay, so this is the correct answer. So now but this is not the final answer, because they have given us a point. What is that point? That point is here they have given, that is point is 1 2 3. Okay, so therefore here we'll write given pointers, given pointers. So in terms of x, y, z, if you write, then x, y, z is equals to 1, 2, 3. That means x is equals to 1, y is equals to 2, z is equals to 3. So now wherever x, y, z are there, okay, instead of x you have to put x equals to 1, y is equals to 2, and z is equals to 3 in this equation. So therefore curl f is equals to e to the power 1 into 2 into 3 in the bracket. This is 1 in the bracket 3 minus 2i plus 2 in the bracket 1 minus 3j plus z is 3 and y is 2 minus 1k. So the final answer here is e to the power 6 in the bracket 1 into 3 minus 2. 3 minus 2 is 1 into 1, that is 1. This is I. 2 into minus 2. This is minus 4j. And this is 3 into 1, that is plus 3k. So this is the final answer of the first example. Okay. So yes, e to the power 6 in the bracket I minus 4j plus 3k is the answer. That means the answer for this particular first example. So now I'll go to the second example. Yes, the second example here is, that is second one, find the curl of f is equals to x square yi minus 2xzj plus 2yz k at a point 1, 0, 2. Again the similar example. Okay, same thing we need to do. So now the solution here is, let first you write given f is equals to x square yi minus 2xz plus 2yz k, and call it equation number 1. Here what is f1, that you know, this is f1, this is f2, this is f3. So therefore f1 is equals to x square y, f2 is equals to minus 2xz, and f3 is equals to 2yz. Yes, these are F1, F2, F3. So now next, according to what that same example, so now I'll go for what that is by the definition of curl. We have that is curl F is equals to del cross F is equals to determinant I j k dou by dou x, dou by dou y, dou by dou z, and here it is x square y minus 2xz, this is 2yz. Yes, so now apply the same thing, that is dou by I, that is first row, first column, first row I have to leave. Now dou by dou y of that is 2yz minus dou by dou z of minus 2xz. Yes, minus j in the bracket dou by dou x of 2yz minus dou by dou z of x square y, close it. Next, plus k in the bracket dou by dou x of minus 2xz minus dou by dou y of x square y. Okay, so now that means curl F is equals to, now elaborate this. So here in the first term, dou by dou y of 2yz, that means 2yz will be differentiated partially with respect to, that is y, that means 2y and z will be kept as it is, differentiation of y is 1, so therefore here we'll get I in the bracket, that is 2 times z, minus dou by dou z of minus 2x, that means 2x will be kept constant, and differentiation of 2xz will be minus 2x, that is minus 2x, minus j in the bracket, minus j with respect to x we are differentiating, so here x terms are not there, so therefore here it will be 0, minus with respect to z we are differentiating but z terms are also not there, so therefore minus 0, plus k in the bracket, with respect to x we are differentiating, therefore minus 2 and z are kept constant, so therefore minus 2z. Okay, next minus with respect to y we are differentiating, so therefore this is x square. Okay, so the finally curl F is equals to that is 2, you can take it outside, that is x plus z I, this will be 0, leave it, plus plus means minus sign we can write, minus this is x square plus minus sign I have taken common, x square plus 2z, that is k. So this is your curl F. This is your curl F. Therefore, next is the given point we need to take. So what is the given point? Therefore, given point is x, y, z is equals to 1, 0, 2. 1, 0, 2. So therefore x is 1, y is 0, z is equals to 2. So now put it here. Therefore curl F is equals to 2 in the bracket, x is 1, z is 2 I minus x square, that means 1 square plus 2 into, that is 2, this is k. Therefore curl F is equals to 2 in the bracket, 1 plus 2 it is 3, 2 3s are, that is 6 times I minus, here it is 1 square is 1, this is 4, 2 into 2 4, 1 plus 4 that is 5, minus 5 times k. So this is the curl of the second example. So 6i minus 5k. Yes, so like this we can do as many as examples you want. So therefore next what I'll do is I'll skip some of the examples. Okay, already I have given a notes, you can go through that notes later. Many examples are solved here, even third example is also solved. Now what I'll do is I'll go to next example. I'll, yes. Yes, I'll, okay. So we shall have the next example. That means we need to prove the given example is irrotational. So therefore, now I'll take up the next example. Sure. The same definition I'll be using. So therefore, I'll be keeping this one. Yes. So next example number 3. According to our notes, it will be example number 5. But here I'll write 3. That is, third example is prove that f is equals to 6xy plus z cube I plus 3x square minus zj plus 3x z square minus y into k is an irrotational. Full point. Find a scalar function. Find a scalar function f such that f is equals to del f. F is equals to del f. Okay. So now let me start with this example. Solution. First, what they have given will write. Let f is equals to, that is given 6xy plus z cube I plus 3x square minus zj plus 3x z square minus y into k. Call it equation number 1. Here what is f1? Here f1 is equals to 6xy plus z cube. f2 is equals to 3x square minus z, and f3 is equals to 3x z square minus y. Okay, and again, so why I kept this one is because the same definition will be continuing. Okay, because by using curl only we are going to prove, that is, what do you mean by irrotational? That means if curl f is equals to 0, then we can say that given f is irrotation. So therefore, the same definition I'll be keeping now, which is equal to so this we don't want otherwise. So here f1, f2, f3 will write. Okay, that is f1, f2, f3. Now you can put the f1, f2, f3 values. I, j, this is k, dou by dou x, dou by dou y, dou by dou z. f1 is 6xy plus z cube. 6xy plus, that is, z cube. Next, 3x square minus z, and here it is 3x z square minus y. Yes. So now okay, so therefore curl f is equals to, okay, curl f is equals to, so already you know. So how to do that? I in the bracket dou by, you can see first column, first I have to leave dou by dou I into this much, dou by dou z into this. Okay, so therefore dou by dou I of 3x z square minus y minus dou by dou z of, that is 3x square minus z. So close it. Now minus j in the bracket dou by dou x of 3x z square minus y minus dou by dou z of 6xy plus z cube. Next, plus k in the bracket dou by dou x of that is 3x square minus z minus dou by dou y of 6xy minus that is z cube. Okay, we'll check it. So now, so therefore curl f is equals to, you can see we are differentiating this with respect to y. So therefore here in the first term there is no y term, so therefore this will be 0, and here there is a y term. Therefore what you will get, I in the bracket, this is first term derivative will be 0 with respect to y, and for this is minus 1. Okay, and now here it is with respect to z we are doing, so therefore here this is minus sign and this will be 0. This is minus z is there, here one more minus is minus of minus, it is plus, so therefore this is plus with respect to differentiation of z with respect to z is, that is 1. Okay, that is 0 minus 1 minus 0 plus 1. Okay, next minus j in the bracket, that is with respect to x if you differentiate, so what you will get, that is 3 times that is z square, because with respect to x we are differentiating 3 and z square are constant and derivative of x is 1 with respect to x is, okay, minus with respect to the derivative of y with respect to x is 0, right here 0. Next minus, next with respect to z if you differentiate this will be 0 minus of plus, that is minus only, with respect to z if you differentiate z cube then you will get 3 times z square. Okay, next plus k in the bracket, so here I write, so plus k in the bracket with respect to x if you differentiate, here you will get 3x square becomes 6x and this will be 0, minus with respect to y if you differentiate then this will be minus 6x, minus of minus it is plus, with respect to y derivative of z cube is, that is 0. So you can see minus 6x plus 6x it cancels, minus 3z square plus 3z square it cancels, plus 1 minus 1 get cancelled. So what you will get, that is curl f is equals to 0i plus 0j plus 0k, or else we can call that is 0 vector. So therefore f is an irrotational vector point function. Okay, this completes the first part. That means what the first they said, prove that f is irrotational. So we have proved, that is curl f is equals to 0 vector we got. So therefore that is f is an irrotational vector point function. So now the second part is find a scalar function f such that f is equals to, that is this is a vector point function, f is equals to, that means del f means this f is, that is scalar point function, and this we can call, that is gradient. That means, so by taking this the hypothesis, so we need to find what is the scalar point function f. So therefore now I'd like to start with that, the second part. Yes. So here I'll write next. So what they have given, next f is equals to, that is gradient of f. So therefore f I'll be writing as f1i plus f2j plus f3k. And what do you mean by the gradient of f? That already you people know. That means I dou f by dou x plus j dou f by dou I plus k dou f by, that is dou z. Okay, but what is this f? F is given, okay, in the equation 1. So therefore just you write it. That means 6 times xy plus z cube I plus 3x square minus zj plus 3x z square minus y into k, which is equals to I dou f by dou x plus j dou f by dou y plus k dou f by, that is, dou z. Now you can see, guys, this is equality of two vectors, okay? Equality of, this is one vector I j k, here I j k. So therefore equality of two matters. That means I coefficient is dou f by dou x, here I coefficient is 6xy plus z cube. So therefore by equality of two vectors, we have that is dou f by dou x is equals to 6xy plus z cube. Next, dou f by dou y is equals to, here it is dou f by dou y, that is equal to jth coefficient is, which is equals to 3x square minus z. Similarly, dou f by dou z is equals to 3x z square minus y. So now you can call it as equation number 2, this as equation number 3, and this as equation number 4. Okay, so equation number 4. So now actually our interest is to find this f, because they said find a scalar function f, that is scalar point function f we need to find. But here f is there in all the three equations, 2, 3, 4. So therefore we need to find, here f is there as a differentiation, partial differentiation with respect to x, here partial differentiation with respect to y, and here partial differentiation with respect to z. So now we will differentiate this with respect to x, integrate this with respect to x, integrate this with respect to y, and integrate this with respect to z, and we'll see so what we will get. Okay, so therefore now here I'll say integrate equation 2, 3 and 4 with respect to x, y and z respectively. We get, so that means what, equation 2 will be integrated with respect to x, 3 will be with respect to y, and 4 will be with respect to z. Then we will get, here if you put an integration sign, and with respect to x if you differentiate, what you will get in the LHS side, you will get f is equals to integration of 6xy plus z cube, with respect to x we are doing, that is dx, plus there is a constant, okay, because when you integrate then you will get some integration constant, but here constant will not come because it is a here this is a partial differentiation. So therefore here you will get function of f of y comma z, because I'll tell you, if you differentiate this with respect to, again with respect to, that is what, x, then this is a function of y z, that means it will be treated as a constant and this becomes 0. So therefore we will not write the constant c, instead of writing constant c we will write a function of y and z, because with respect to x we are differentiating. Okay, and in this case we will not write constant c, here we will write a function of, with respect to y if you integrate, then here we will write a function of x and z, and here we will write a function of x and y. So therefore f is equals to, with respect to x we are differentiating, so therefore 6 and y are constants, so we are integrating with respect to x, so therefore 6 and y are constants, and integration of x with respect to x is x square by 2. So therefore here we will get 6x square y by 2 plus this is x z cube, because this is a constant, so therefore x will come, so x z cube plus this is f of y comma z. That means if you elaborate it, here you will get 3x square y, because 2 1s are 2 3s are, plus x z cube plus f of y comma z, and now call it as equation number 5. Similarly equation 3 with respect to y we need to integrate. So therefore f is equals to integration of 3x square minus z into dy plus, that is g of something function of, okay, function of x and z, function of x and z we need, right? So therefore f is equals to, this becomes with respect to y we are doing, so therefore 3x square y minus yz plus g of x comma z, call it equation number 6. Lastly, f is equals to integration of this with respect to z. That means 3x z square minus y into dz plus something h of x comma y. Therefore f is equals to, that is with respect to z we are integrating, so there so we'll get 3x z cube by 3 minus 3x z square is with respect to z we are, okay, this is y z, plus h of x comma y. So therefore f is equals to 3 get cancels, x z cube minus yz plus h of x comma y, and call it equation number, that is 7. Okay, so now actually we got f in 3 forms, okay, that is equation number 5, equation number 6 and equation number 7. But in that f of y comma z is unknown, here in this case f of x comma z is unknown, and in this case f of x comma h of x comma y is unknown. So therefore now you can compare equation 5 and equation 6. You can see 3x square y is there, 3x square y is there. Okay, so now you can see guys, here this is y minus yz is there, but here it is not there. Here it is plus xz cube is there, but here it is not there. Now you can compare these two. That means f of y comma z means what? This is a function of y and z. Here there is a function of y and z. Okay, so therefore we can compare this f of y comma z with what? This. So therefore we'll get this much. Now this is a function of x and z, and here it is g of x comma z. So comparing equation 5 and 6, we get f of y comma z is equals to, okay, if you compare this with what? This, then y comma z is what? That is minus yz, and g of x comma z is that is x z cube. Okay, so that's enough, because if you get one any one of what, that is f, g and h, then our job is over. So therefore equation 5 becomes, because f y comma z we found, so therefore equation 5 becomes f is equals to 3x square y plus x z cube, and f of y comma z is minus yz. Okay, so this is your scalar point function. Okay, so we can find a scalar point function in this particular way. Hope you understand, right? So now I'll go to 2 more examples on this, and remaining all will be homework for you. Yes. Okay, so now I'll start with the next example. Okay, write down. Prove that example number 4. Prove that del cross del f is equals to 0 vector for any scalar point function f. Okay, is, let us start with this. Let f be the scalar point function. Yes. Before going with this, first you find what is del f. Del f means what? That is gradient of f. Okay. So we know that we know that gradient of f or grade f is equals to, that is del f. That is equals to, I will write I dou by dou x plus, sorry, I dou f by dou x plus j dou f by dou I plus k dou f by dou z. Okay, call it equation number 1. Okay, this is del f. Now we want del cross del f. Okay, that means del cross del f we want. Okay, next we'll consider that del cross del f. Okay, we know what is del. Del is what? I dou by dou x plus j dou by dou I plus k dou by dou z. Cross. Okay, because cross is there, cross. And what is del f? Del f is here I dou f by dou x plus j dou f by dou I plus k dou f by dou z. Okay, so that means, again, you know, so while finding a curl, already people have studied this. That means what? The cross product of two vectors can be written as determinant I j k. This is dou by dou x. Okay, this is dou by dou I, and this is dou by dou z. And here dou f by dou x, dou f by dou I, and this is dou f by dou z. Okay, determinant, right? So now which is equals to del cross del f is equals to I in the bracket, first column, first row, just to leave it. Then now here you will get dou by dou I of dou f by dou z minus dou by dou z of dou f by dou I. Okay, next minus j in the bracket, dou by, you can see j in the bracket. That means this column and this row. That means second column and first row we need to leave. This we need to take. So therefore, dou by dou x of dou f by dou z, dou by dou x of dou f by dou z minus dou by dou z of dou by dou z of yes, dou by dou z of dou f by dou x, dou f by, that is dou x. Now plus k in the bracket. Next third column and first we need to leave. So this into this minus this into this. Dou by dou x of dou by dou x of dou f by dou y minus dou by dou y of dou f by dou x. Okay, so therefore here you will get del cross del f is equals to I in the bracket. So dou by dou I of dou f by dou x. What you will get? That is I in the bracket dou square f by, because dou into dou square, it is dou I dou z minus here again dou square f by dou z dou I, both are on the same. Okay, so next minus j in the bracket, dou square f by, that is dou x dou z minus dou square f by dou z dou x. Okay, next plus k in the bracket, dou square f by, that is dou x dou y minus dou square f by dou y, dou x. Okay. So here these two get cancelled, these two get cancelled, these two get cancelled. Okay. So therefore, what you will get? Del cross del f is equals to 0i plus 0j plus 0k. That means del cross del f is equals to, that is 0 vector. Yes. So this completes the what, that is fourth example. Yes. So once if you know about this, the gradient of f and the curve, this is the definition of curve. Okay. Cross means what? You can use the definition of curve. Okay. That only I have used, and finally I have proved that del cross del f is equals to 0. So one can very easily do this particular example. Yes. So now one more last example I'd like to do, and that is, yes, where is that? Yes. So prove that del dot del cross f is equals to 0. Okay. So now I'll take that now. Yes. So one more last example on this particular the concept, that is curve. So example number 5. Prove that del dot del cross f is equals to, that is 0, where f is vector point function, where f is vector point function. Okay. So now we shall finish it fast. So solution, let first you write what is given f is. Okay. I'll write it in terms of f1i plus f2j plus f3k and call it equation number 1. What do we want first? That is del cross f. Okay. So therefore del cross f already you know. That means what? Curl of f. How will write? That is I j k dou by dou x, dou by dou I, dou by dou z, and here it is f1, f2, f3. Yes, which is equals to I in the bracket. So I will write, that is dou by, directly I'll write. Okay. Why we have to waste our time? Yes, this row, this column, this row I have to leave. Dou by dou I of f3. That means dou f3 by dou I minus dou f2 by dou z minus j in the bracket dou f3 by dou x minus dou f1 by, that is dou x, plus k in the bracket, that is dou f2 by, that is dou x minus dou f1 by, that is dou I. Okay. So this is what? Del cross f. This is del cross f. So if you want to rewrite it, you can write it del cross f is equal to, that means I want to write I next. So therefore this is dou f3 by dou y minus dou f2 by, that is dou z. So here it is I. Minus sign is there, I want to make it positive. That means minus sign I'll take it common, so therefore this becomes positive. That means dou f1 by dou x minus dou f3 by, that is, sorry, here I have made a small mistake. With respect to x means it is f3 by correct, that is this is z. With respect to this will be z. Okay. So that means it is z, this with respect to x correct. Okay. So this is plus, here it is j. Next this one you have to write as it is dou f2 by dou x minus dou f1 by, that is dou y. Okay. So and here it is k. So this is del cross f. What we want? We want del dot del cross f. Okay, del dot del cross f. Dot means what? Already it is there, which is equals to, how will write? I dou by dou x plus j dou by dou y plus k dou by dou z, and this dot del cross f, it is already there, you can write it. Okay, here it is there, del cross f. So how we can write this one? Coefficient of this into this much we need to write. Okay, so therefore dou by dou x of this much, that means dou f3 by dou y minus dou f2 by, that is dou z, plus dou by dou y of this, that means dou f1 by dou z minus dou f3 by, that is dou x. Lastly, plus dou by dou z of this much, dou f2 by dou x minus dou f1 by, that is dou y. So now elaborate this. With respect to x, you differentiate. Okay, with respect to x, if you differentiate, what you will get? Dou square f3 by dou x dou y minus dou square f2 by dou x dou z. Here plus dou square f1 by dou y dou z minus dou square f3 by dou y dou x. Lastly here plus dou square f2 by dou z dou x minus dou square f1 by dou z dou y. Okay, so this is dou square f1 by dou y dou z, dou square f1 by dou x dou y, both get cancelled. Next, this is dou square f2 by dou x dou z, and dou square f2 by dou x dou z get cancelled. Okay, and dou square f3 by dou x dou y and dou square f3 by dou y dou x get cancelled. So finally here you will get del cross f is equals to, that is 0. Okay, so this completes the example. So we shall stop here. In the next class, so directly we'll go to, that is double and triple integration. Yes, thank you.